Hi there. Well, just to start, I have to say that it's been a massive pleasure to work with all of you guys, and then I have to admit that I'm a bit sad, but well, that's life. We're going to talk about, well, basically new data, but focused on improving emission inventories of greenhouse gases. The basic, very basic idea is that if you have a piece of land that it's a grassland and suddenly it's going to transform into a patch of agriculture, you have a change in biomass, and therefore the carbon is going to be stored somewhere else. Therefore, what we want is to quantify these changes in land cover to be able to improve emission inventories. First thing, it was about what exactly our users need. So directly from the first meetings, we identified that we need, well, first of all, annual estimation of changes in area. If possible, 10 years of data or more. And something very important, it was about characterization of errors. In the end, you have to construct a very good relationship with your user to identify not only what is feasible, what they want, but to create a real synergy between what you can do and what they really need. From this, well, first thought it was, well, yes, of course, we need a land cover product to map changes every year. However, we have tons of products available in the market. Nevertheless, we didn't have one that it was just fit for our purpose. We had several products that they were produced at very high spatial resolution, 25 meters pixel size. Some that were produced every year, and that was really great, but there was no product exactly to fit our needs. So, well, then we decided to develop our own. But the basic idea actually is not to just create a land cover map. It's actually to characterize the land surface in the UK. And that's, well, it sounds quite simple, but it's quite a big challenge. Just think about, you have satellite data. From there, you need to see what's happening over time. Then you use a time series of surface reflectance, which is, well, just the amount of energy reflected by the land surface if you don't have any atmospheric effects. Then once you have this time series, well, you create a sample database just to train an algorithm and to say, well, this pixel is agriculture, this pixel is grassland, and then you perform your classification, and then you identify your changes. Okay, piece of cake. However, well, this is the UK underneath the clouds. I think you are people living there. We are familiar with, well, how many days we have clouds in the UK. I actually have the number, and it's huge. Then the main challenge is, well, we have daily data, open data, and that's wonderful. One of the, I mean, without access to this data set, to the modeling data set, it would have been almost impossible for us to derive this time series. However, we designed the framework in a way that it's possible to ingest different data sets. You just have to adjust a few things, but it is possible to ingest some more data. So how can you go from something like this to something like this? A beautiful cloud-free time series of the United Kingdom. We developed, well, a nice code that it takes all these cloudy images, and then you have a nice time series cloud-free of surface reflectance from 2003 up to 2015. So first step, we're fine. Then a sample database just to train our algorithm. What you see underneath is just the land cover map from the Center for Ecology and Hydrology in the United Kingdom. And that's a very nice product because every pixel is 25 meters, so we have very good representation of all land cover classes in the UK. And then the grid is the simulation of the MODIS pixel. And then we have to say, okay, when we have a pixel that is surrounded only by pixels of the same class, we can consider that it can be used as a training data set. We performed some other stuff. In the end, we ended up with about 87,000 pixels. And then, voila, we have a beautiful land cover product. Thing is that what you are seeing is only actually one product of our set of products, because in every year what we have is, well, for every class, for every pixel, a probability of what's the land cover in that particular pixel. You are seeing the most dominant class per pixel from 2003 up to 2015. Therefore, the main idea of this MELODIES land cover framework is that we are using only open data, only open source programming languages. If you want to have fun and just to create your own land cover map and then derive some changes and have fun using open data, well, you have all the code in GitHub. It's a product that is focused more on changes rather than creating individual products. You have a nice portal, have it your way. You can download the land cover in different formats. And the thing is, for the future, we are really looking forward to enjoying some time ingesting data from some other sensors, and why not maybe go back in time, because that was one more requirement of our users. If possible, go back in time and have a nice product spanning almost 30 years. And this is it.